Hello everyone, today we'll be going over a calculus tutorial series, and today we are focusing on the concept of sums, differences, products, and quotients. Now, to be able to give a brief overview of exactly what we are focusing on, so when dealing with functions in different forms and combinations, we would have a series of graphs that could vary depending on exactly how the functions would behave, mainly in the case of if we add them together, subtract them, multiply, or even divide as well. So within such respect to the behaviors of each of the following functions whenever we combine them, we also need to take into consideration about their domain and ranges. Now, for the rest of this whole portion over the following concept that we're going over, sums, differences, products, and quotients have a key relationship that can discern between how we can figure out their domain, ranges, altogether. Mainly, we would have to consider whenever we add, subtract, multiply, or divide, the domains, which typically refer to the x-axis, or really the combination of the area of our functions, especially from a graphical standpoint. And that goes for all domains we have for each of the following behaviors for combining functions. Let me just move this bullet point out. And the ranges, on the other hand, can also be said of the same behavior for the domains, except the key differences we are focusing on the values. So it's when it's the values produced by the combined functions. And things to also to consider as well. We already know, based on the nature of our functions, functions typically have an independent variable, which would typically refer to the x, and a dependent variable, which refer to our y, f of x, or g of x, just to consider. If we were to go over an example, namely whenever we are trying to combine the functions together, let's say we are going for addition. So let me just move this really quick to be able to help minimize and then showcase our example. So if we were to have the following combination between summing, I would say, the square root of x and then 1 over x minus 2, when we are adding them together, we first have to consider 1, the nature of the separate functions, list and know they're separate, domain and ranges, the third part, we need to combine them together. Fourth, show the graphs. for each of the functions and when they are together. They are together on the same graph. So let me just minimize this to be able to help filter cement. Let me just move this. Here we go. Here we go. Cool. All right. Here we go. So, namely, if we wanted to, and I'll just map this out over here. So we would have for x plus 1 over x minus 2. First step that we would do, just going over 1, is that for the square root of x, we would have to know its domain. So typically, along with its range too, sorry. So once we already have done the first part, we would just move over to our second part. We would just put them out separately and dissect them, and we would listen to know the domain and ranges. And I'm actually going to combine 3 and 4 for this to be able to help. Because what I'm going to be doing is I'm going to show you the graph as well. So we're going to work our way backwards for a little bit to be able to help. So, namely, if we were to look at the square root of x, the square root of x is typically denoted in this shape that we have. And the domain is always referring to the x-axis, and the range is always referring to the y-axis. So, our domain, in of itself, in the proper notation, would be all the values, including 0, all the way to positive infinity. That would be our domain. And the ranges, we can also say the same thing. 0 all the way to positive infinity. And now for the other function that we have over here, let me just create some extra space over here. There we go. The second part, we would have 1 over x minus 2. Let me just state this right here. So 1, 2, 3, and 4. We can just work backwards, and then we will know. So I'm going to point out the graph first. So typically, in reciprocal functions like this, so we would have 1, 2, 3, 4, 5 at the 2, because if we were to, for instance, have our function f of, make some space over here, we would have f of x is equal to 1 over x minus 2, and we were to plug in 0, or actually, if we were to plug in 2 in this case, we would have f of 2 is equal to 1 over 2 minus 2, and we cannot divide by 0. So technically our graph is going to look like this. Here's a better visualization. All right. Voids 2 that way. And we would know our domain and range. Our domain is going to be including negative infinity to 2 since it's not going to be including 2, that's why we don't have the bracket compared to over here, because 2 is being completely separate. It's sort of like its endpoint. And then the domain for the reciprocal function, there's always a unison. So right here, unison to 2 to positive infinity. We notice on the x and the y axis as well. And our range, on the other hand, given the fact that we're focusing on our y-axis, it's going to be negative infinity to 0 in unison to 0 and positive infinity all together, since we're focusing on the y-axis, not the x-axis in this case. We notice in particular that it's at 2 and 0, and so that is why in particular there's sort of like this axis of symmetry that is right here, this invisible line. And so that is why we determine our domain and range when we especially look at it from a visual standpoint and understand the nature between both of them. Now, if we were to combine them together, this would be step 4, the most critical point. Actually, let's do a different color. Combine them together. We would typically have a graph that would look like this. And draw a better one. There we go. So for the first one, I'm going to do this one, square root of x, and then we have 2, 5. There we go. And then we would have 1 over x minus 2. And then when we combine them together, we have to look at the domains and ranges respectively. And what we would need to consider is exactly which one is the most dominant one. Ask ourselves which is the most dominant area both functions cover. And so it looks like, since we already have our domain and ranges, so our domain would be, in this case, actually I'll use this white color over here, since we know it's 0 to infinity, and then we know that for 1 over x minus 2 is going to be, we know it's negative infinity, negative infinity to 2 in unison, 2 to positive infinity. Well, both functions at their intersection looks like they're going to be covering this part mostly over here. So right at their intersection is where their dominant area is actually going to be. So we can say our domains are going to be this part and this part. The intersection is not happening over here. So we'll just get rid of this. And we're just going to combine these two together, which means the domain is going to be for both. It's going to be 0 to 2, since we're starting at 0, going all the way to 2, in unison with 2 to infinity, since we're at our intersection as well. This is where both graphs come together, and they form the dominant area between both of the functions being combined together. In fact, I'll just add a fifth point as well. We will ask ourselves the most dominant area for both functions. And it could be intersecting / combining. now when we focus on the range, actually, the range is actually going to be quite unique because given the fact, so all we have to do whenever we are combining is that we need to just look at our ranges between the range for the square root of x, which we know over here is going to be including 0 all the way to positive infinity, and we know for the y range we have over here for a reciprocal function, given the fact that we're only looking at the y-axis, we're seeing what is not, for reciprocal functions, what it's not touching. The range for the reciprocal function is going to be negative infinity to 0, unison. Let me just move this over here. Negative infinity to 0, unison to 0 and positive infinity. When we have done so, all we need to do is that whenever we are looking between the ranges, now, even though the range over here is not including 0, it's only just getting the ranges from negative infinity to positive infinity and then just skipping 0 accordingly, as if we are moving up and down the following graph. Then for the range on the square root function, we're actually including 0. So the range for both of them is actually going to be negative infinity to positive infinity, because we're also including 0 in this case between this following function here, despite skipping 0 for the reciprocal function. We're including the range over here for our square root, and then we're also including the range for our reciprocal function as well. So this would be our range, and this will be our domain. So let me just move out to be able to help further solidify and clean this up. Now, feel free to take a screenshot of each of the following parts. I'm going to move from left to right so you can actually take screenshots of the following lecture slides, since we did cover quite a bit of depth in order to cover our full understanding between domains and ranges and combining functions in our example with our sum. We are then going to be moving over to practice problems for each of the following for sums, differences, products, and quotients as well, so we can further solidify our understanding between how we combine various functions along with their visual representation within graphs. So feel free to take a screenshot of this part, and feel free to pause the video, and I'm going to move over to the right. There we go. Feel free to take a screenshot of this part as well. Pause the video if you need to. Yeah, there we go. Feel free to pause the video at any time to take a screenshot. And now, moving over to the left. Now we'll be heading over to sums and focusing on our practice problems for them. Hey everyone, thank you again for taking time to watch this video. If you found this video helpful, be sure and feel free to please like and subscribe. And if you have any other questions as well, feel free to put it in the comments section. And as always, take care. Cheers. Bye-bye.